Alright, so I shot a video already, and I stopped to check my work because it seemed absurd. I filled up a couple of pages here. I'm going to walk through it again with you. I really think it's definitely worth asking the instructor or your TA whether the intention is to do this homework problem by hand or to do it with a calculator. And the reason I ask that is these numbers are a little silly, in my opinion. That's not meant to question the instructor's choice. But to get the inflection points, you need to take a couple of derivatives. Right? So here's the first derivative. You get to check your multiplication skills. That's plus 0. So then the second derivative, 240x cubed plus 540, I think. Yep. X squared minus, oops, I forgot a squared here. Minus, whatever, 2,160x. And so we want to set this equal to 0. Now this is a bit annoying to do. So my thought is, you want to factor. You want to pull out an x. There's certainly an x in common. But these numbers are all even. In fact, it's all a factor of 10. There's a couple of ways you could do this. Let's do some steps maybe. So I'll pull out a factor of 10 and see what happens. I have 24x squared plus 54x minus 216, right, equals 0. They're also even, so I should pull out another factor of 2. You could do this several ways, but if I pull out a factor of 2, then I'll have 12x squared plus 27x minus 108 equals 0. Now, they're not even anymore. So what else goes into them? Well, 3 goes into 12, 3 goes into 27, and if you think about it, 3 goes into 10 3 times with a remainder of 1. 1 and 8 is 18, 3 goes into 18. So yeah, you can pull a 3 out. That's 4x squared plus 9x minus, so what did I say there? It goes in 36 times. So that's kind of obnoxious. Now to find the inflection points, the first step is to find where the second derivative equals 0. So x equals 0 is going to be one of them. So the reason I question this problem is that this is a little obnoxious. This doesn't factor into whole numbers. So we'll have to use a quadratic formula. It's minus 9 plus or minus the square root of 81, that's b squared, minus 4 times a times c all over 2 times 4. Okay, so that's kind of obnoxious. It would be helpful to simplify this as well, because it's not going to simplify down to an integer. 9 goes into 81, and 9 will go into this number, because 9 goes into 36. So what I'm saying is, I can factor a 9 out of these two numbers. Ultimately, there's going to be two numbers here, and I don't want to actually work this out. So this is 9 minus, actually it's plus. That's 16 times 4 is 64. All over 8. I can pull the 9 out of the square root by taking the square root, meaning this is root 9 times root 73 over 8, which is minus 9 plus or minus 3 root 73 over 8. So what are your three possible inflection points? Well, there's 0. Let's put them in order, actually. It's minus 9 minus 3 root 73 over 8, then 0, then minus 9 plus 3 root 73 over 8. How do I know this is positive? You can estimate this is going to be bigger than the square root of 64, which is equal to 8. If that's about 8, This is 3 times 8. That's definitely bigger than -9. The numerator is positive. It's greater than 0. So I have these 3 numbers. Now, you did end up getting right the intervals. And so I just want to talk about how you would do that if you had found these. So, what do you do with wicked ugly numbers like this? So I have minus infinity to, and the key is here, the other night I said, sometimes it's useful to pick ridiculous numbers, and it is, and I'll show you what I mean in this example. Because if you have critical points or inflection points that have radicals like this, things that you can't simplify, and if you're also not using a calculator, and so you can't get a decimal, then you have to find some numbers that are reasonable to use. I don't really care what this number is. I'm going to choose -1,000. Okay? Why am I going to do that? Well, the second derivative that I have up above, 60x times 4x squared plus 9x minus 36. This is my second derivative. I just have to figure out if it's positive or negative. And I can't stress this enough. It doesn't matter what it equals. It just matters whether it's positive or negative, or 0, because of the inflection points. So it's all right. So why do I choose a ridiculous number like -1,000? Here's why. If x is -1,000, what's that? 60 times -1,000 is a negative. Negative times, oh gosh, what's that? Remember, it doesn't matter what it equals. 1,000 squared is 1,000,000. 1,000,000 is bigger than 1,000. So this term is the only important term. Try it on a calculator. This is going to be -4 million. Sorry, +4 million, because you're squaring it. +4 million minus 9,000 doesn't matter. This is a positive, which means the second derivative is positive on this interval, which is concave up, which I remember incidentally by smiling. Concave up is a smile, positive attitudes smile. So, and you definitely had that. What about here? Gosh, another ugly interval. Well, again, this is like 8. That's like 24, -30 something over 8. It's more negative than -1. So I'll choose -1. I don't really care what it equals. This part's going to be negative. It's -60. -1, but that's squared. So it's 4 minus 9 minus stuff. Negative. So at double prime is negative. That's a frowny face. Concave down. What next? Well, in here, same deal, right? You've got -9 plus whatever, 20 something over 8. Again, if this were 64, it would be 8. This would be 24. 24 plus minus 9 would be 15. 15 over 8 is bigger than 1. That's all you have to reason. So I can choose x equals 1. 1 will be between these. I mention all this because it might be the case your instructor thinks this is a good idea to know how to do. And so it's worth kind of thinking about if that's the case. If x is 1, 60 times 1 is positive. 4 plus 9 minus 36, that's still negative. So, whoops, I made a mistake here. I got it all backwards. You've probably been questioning me. Sorry about that. F, it's negative, positive. All right, frowny face, happy face. That's negative. Concave down. And then last, again, I need a number in this interval. So I'm just going to choose x equals a positive 1,000, because 1,000 is actually easier to use. If you choose a number that's too close to a tipping point, it's hard to tell. But 60 times 1,000 is a positive number. 1,000 squared is 1,000,000. 1,000,000 plus 1,000 is bigger than 36. So you have the right sequence of concave down, concave up, concave down, concave up. But the numbers in here are a little messy. So And you know, when Devin said that it looks like you're having more algebra problems than calculus, I can tell you that this is essentially the case for everyone. I'm always telling my students, calculus makes your algebra better. It doesn't make your calculus better. Your calculus will still stink. It's not until much, much later that your calculus gets good. Calc 1 and 2 and 3, it's because you get thrown all this kind of garbage that you get much, much better at your algebra. But I don't know if this helps. I hope it does, babe.